Alright, so in this example, I'm going to be doing an example of an average rate of change problem from a word problem, where not only do we need to solve what is the average rate of change, but it also asks us to explain the meaning of the value in the context of the problem. So let's go ahead and read this example together. It says, after several days of enjoying your pool has sprung a significant leak towards the very bottom of the pool. Uh-oh, this could spell disaster for your summer. Rather than patching the hole, you decide to determine the mathematical equation which describes the rate at which the water is leaving your pool. Thanks to some solid math skills, you arrive at an equation where T is the time in minutes and R of T represents the amount of water flowing out of the pool measured in gallons per minute at T minutes. So here's our equation. R of T equals 3,000 divided by T squared plus 10. This represents the rate of water flowing out of the pool in gallons per minute, where T is our time in minutes. The question says, what is the average rate of change from 2 to 7.5 minutes? Explain the meaning of the value in the context of the problem. Now, I already wrote this down on my paper when I read this problem earlier, that since I want the average rate of change, remember that is a rate, so typically we think about that as our change in y over our change in x. In this case, our y is this rate, so I want like the change in R of T over our change in x. In this problem, we're not dealing with x, we're dealing with our input is T in minutes, so really our change in T is what we're thinking about. So we have our two T values. We have T equals 2 and T equals 7.5, so the change in T, we're just going to be subtracting those. But we need to find the change in our R of T, so we need our corresponding R of T values for these T equals 2 and T equals 7.5. So we're going to start by finding those values for our y values or our R of T. So we want to find R of 2 by plugging in 2, 3,000 divided by 2 squared plus 10. And we want to find R of 7.5 by doing 3,000 over 7.5 squared plus 10. We can plug those into our calculator. Let me pull up my calculator. And for R of 2, I ended up getting 214.286, and for R of 7.5, 45.283. So these are our rates, our y values that are going to go on top, and 2 and 7.5 are our t values that are going to go on the bottom. So we're going to find the change. We're going to subtract. So I'm going to do 214.286 minus 45.283 all over our change in x, which would be 2, because 2 corresponds with the 214.286, minus 7.5. Plug that in, and let's see what we get. We end up with negative 30.72, and rounding that last digit, 8. Okay, great. So here's our answer. That is the average rate of change, but it does say to explain the meaning of the value in the context of the problem. So let's think about units and about a couple of the things we want to include when we're explaining our answer. Now, this average rate of change is only for a specific interval of our function from 2 to 7.5 minutes. So sometimes I like to start by saying my interval. I say from t equals 2 to t equals 7.5 minutes. Okay. What are we talking about? Now, we could say the function, but I want us to be specific in the context of the problem about what this R of T represents. So from t equals 2 to t equals 7.5 minutes, I'm going to say what we're measuring, which is the amount of water flowing out of the pool, the rate of water flowing out of the pool, this is what we're talking about, is, and then remember our negative or positive is indicating for us whether this is a increasing or decreasing rate right here. And since it's negative, we're going to say that it is decreasing at an average rate of, and our rate is 30.728. Now notice I dropped the negative now because I already accounted for that by saying that it is decreasing. So it is decreasing at a rate of 30.728 means that it is a negative. We do not write that on the number right here, or we would be counting for the negative twice, which we don't want to do. Okay, and the last thing is that we don't want to leave this number by itself. I want to make sure that I have units on it. So 30.728 watt. Now let's take a look up here for our units. We can always think of what the units are on the top that we divided by our units on the bottom. The tough part about this problem is that these up here were already rates. R of t was a rate. So this was already measured in gallons per minute. We might be used to it just being something like gallons or miles or something, but this was gallons per minute on the top. And then 2 and 7.5 were minutes on the bottom. So we're going to take a rate of a rate, and we end up with kind of a funky looking unit of gallons per minute, because we took that rate and divided by minutes again, so per minute. Gallons per minute. Another way you could write this would be to say gallons per minute squared, but we do need to account that it's per minute. So all we're looking for here is to make sure that we have our time interval, what we're talking about, the rate of water flowing out of the pool, whether it's increasing or decreasing, at an average rate of how much, we said the number, and then our units, gallons per minute.